Welcome to chapter 1 for Math 99. What is a number? What is a number? It's not a simple question, and I don't have a definitive answer actually. But what is a number? It's a really complicated concept, but all I can tell you is the different ways that we represent a number and kind of putting up those different representations in your head, putting together those different representations in your head gives you an idea of what is a number and what isn't a number. Here's a representation of the number 4, right? Here's a representation of the number 4. Here's a representation of the number 4. These are all representations of the number 4. For this class, I've kind of limited some really useful representations of numbers that'll help you understand how numbers relate to each other. They will be useful for you as you go through this course. What is really useful is to think of a number as something that you could represent on a number. Here's a number line, and we can use the number line to represent numbers two different ways, with a dot on the number line, and what number it represents is given by the distance from 0. So to the right of 0 are the positive numbers, continuing on forever, and to the left of 0 are the negative numbers, continuing on forever. So if I said, where would you represent the number 4? You could put a dot right there. And if I said, where is the number -2? It would be right there. So that's one way to use a number line to represent numbers. And another way to think about a number is an arrow on a number line. The number line itself is an arrow that goes on forever to the right, forever to the left. So look at this arrow right here. It goes from 1 to 3. From +1 to +3. And ask yourself, what number do you think that arrow represents? This arrow right here, what number do you think that represents? This length right here is a length of 2, and the arrow is pointing to the right, so it's a positive number. So an arrow that represents a number that is the distance that the arrow spans and has nothing to do with the location of that arrow. So for example, here's 0, here's -1, -2, -3, 1, 2, 3. Here's an arrow that goes from 0 to -3, and it stops right there. Okay, I'm not showing all the numbers that are less than 0. I'm saying this arrow has a beginning and an end. It begins at 0 and it ends at -3, and that represents the number -3 because the distance that it spans is 1, 2, 3. It spans a distance of 3 and it's pointing to the left, and therefore it's a negative number.
You can have the negative arrow and have it start at a positive number.
So here's an arrow, it starts at 5 and it goes to 2. So it has a beginning at 5 and an ending at 2. What do you think is the number that that arrow represents?
-3.
Okay, what about this arrow? The arrow represents a number. It has a beginning, it has an end, pointing to the left, so it's a negative number. The arrow tells you what number it represents by its length and what direction it's pointing. What's the length of that arrow?
7.
The length is 7. What direction is it pointing? Thinking about numbers with this kind of representation is really useful when you try to wrap your head around the rules about subtractions. Yeah, you had a question.
Why is there not a dot on 3? Why is there a line on 3?
Why is there not a dot on 3? Oh, like right here?
Yeah.
I don't know. I just drew a line there just to say, emphasize this is 3. It could be a dot. What makes you ask that question?
Because there's like the open dot, closed dot thing that people are like,
Mm-hmm.
you gotta remember.
Yeah, that's a great question. So there's the open dot, closed dot things. 2, 3. So can you tell me about that open dot, closed dot thing that you learned about?
Well, if you have like a line between two numbers, like without an arrow, and on either side of the line, there's like either a closed dot or an open dot
Mhm.
that's connecting, or that the line's connecting.
Mm-hmm.
And one of them means it includes the number, and one of them
Yes.
means it doesn't, and I don't remember
Yeah.
which one it is.
Yeah, so I'm really glad you brought this up because you can represent all the numbers between two numbers also with an arrow. What I've been talking about up here is like, this number right here is the number -7. This arrow represents the -7. You could also think about it in a different context as representing every single number between the numbers 3 and -4. And that's really useful in some contexts. So there's this other way that we use number lines, and that's to show if I did like an open arrow and then
Dot,
a line and then a dot, right?
open dot, not open arrow.
I'm sorry, open dot, not open arrow. So open dot, open circle, closed dot, filled in circle. This would represent all the numbers that are bigger than -2, but not including -2, up to 1 and including 1 because it's a closed circle. And sometimes people draw arrows like that. And there's an infinite number of numbers between these two, right? Between the number -2 and 1, there would be an infinite number of numbers. You could never count them. It would be an uncountable set because there's always one number between any two numbers. You could always make a little tiny change and there's another number. Okay, in this class, we're going to be talking more about arrows representing a specific number, not all of the numbers that are spanned by that arrow. Okay, so far we've talked about representations of numbers. You could have a dot on a number line, an arrow on a number line that represents a specific number between two numbers. It's the difference between two numbers. It has to do with subtraction. Another way to think about a number is number of repeats. And so here's an arrow. Let's call this I don't know, let's say that's the number 3. So that this length right here is 3. Here's another one, here's another one, here's another one. Okay, ask yourself, how many numbers do I see represented in this picture? First of all, I don't know where on this number line these little arrows are. I mean, this could be the number 1,000, this could be the number -1 billion, it could be 0, it could be anything. I didn't label my number line. All I know is that these arrows are lengths. So what do you see?
4,
4 different numbers? What are they?
3, 3, 3, 3, 3.
1, 2, 3, 4. So you see 4 different numbers. What about the number 4?
No,
You don't see that represented?
no.
So I'll tell you another way that you can think about numbers is just counting. So here's 1, 2, 3, 4. So I would say that I see the number 4 right there because it's the number of things. So say here's a bunch of squares, right? What number does that represent? I can say, well, I see the number 5 because I count 5. Here I see 4 arrows, so it represents the number 4. Does that make sense? Yeah. Any other number that you might see represented there?
$11.
How do you see 11? What do you see?
There's 11 lines in the thing.
In this thing?
Mm-hmm.
1, 2, 3, 4, 5?
And then each section, 6, 7, 8, 9, I guess 10. 9.
6, 7,
Maybe I just
8,
can't
9.
count. Maybe I can't count.
So you're counting like the ends, like 1, 2, 3, 4, 5.
Yeah,
Okay, so 5 ends and then the middles,
yeah.
and you count. Cool. So it's like if you're building a fence, how many and the fence goes from here to here, how many fence posts do you need?
Sure.
Sure. All right. 1, 2, 3, 4, 5. You need 5 fence posts. But how many fence panels do you need? 4. 4 fence panels. How long is your fence? What? How long is your fence?
12.
12.
Small.
All right. There's another number. You see right there.
8.
Oh, how do you see 8?
Flip around 1 3 and attach it to the other 3. Make an 8.
What? Oh wait, I didn't write down one of your numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, yeah, 9. All right. So I could keep going all day. There's lots of different numbers that you could see there, and the idea isn't that there's like one right answer. there's wrong answers, but there's never one right answer. There's many, many different ways to look at things, and feel free to be very creative, okay? The way I see things might not be the way you see them. If you can justify how you see them, that's mathematical thinking. Justify them logically, that's mathematical thinking.
Flip around a 3, put it on another 3, there's an 8.
What'd you say? All right, so do you see the number 8? Because if you take the number 3 and then take the mirror image of it, then you make the number 8. All right, I would say that is not mathematical thinking. That is like artistic thinking, which is great, but
Wrong!
but that's wrong. I don't see the number 8 in there. Okay. Negative numbers. Are you ready? Negative numbers. A number is a negative number if you can represent it as a dot to the left of 0 on a number line, if the number line is horizontal. Ooh, but there's also vertical number lines, right? Here's 0, and here's 1, 2, negative 1, negative 2, negative 3. And a vertical number line goes on forever and ever up and goes on forever and ever down. If you're lower than 0, if you're below 0, those are negative numbers. So if you can represent a concept like a dot on a number line, then that concept can be represented with a number. Put a dot on the number line. There we go. That dot right there is negative 3. And I want to say this negative 3, there's two symbols right there, right? Like dash thing, and then there's the digit 3. That whole thing is one number represented by those two symbols, okay? It's one number. This symbol right there is confusing because it means so many different things. We use the same symbol to mean so many different things. This is what it means. It means negative sign. It also means the opposite of, and I'll get to that in a second. It also means subtract. All right, what does subtract mean? It means difference, between, and it means like take away. We have a whole chapter on subtraction and the rules of subtraction and where they come from, but so this is just a short introduction. So for example, if I said negative 3 and I said, what is the opposite of negative 3? Okay, what does that mean, opposite of? Think about a number line. The opposite is like the mirror image. You're flipping it around 0. So let's do a point. Here's 0, here's negative 3. The opposite of that number right there would be I'm flipping and I'm finding its mirror image over here. So the opposite of negative 3 is going to be 3. The opposite, we can use this negative sign. So the opposite of negative 3 looks like that.
What about if you do it with an arrow? Because if you do it with an arrow, you're not flipping it over 0.
Ooh, that's a really good question. Okay, so what's the opposite of negative 4? All right, so here's an arrow, negative 4. What's the opposite of that? Flipping an arrow just means you're switching its direction. So the opposite of that is going to be that. So it has the same exact length, but it's pointing the opposite direction. Okay, so when you take the opposite of a number that's represented like a point on a number line, you take its mirror image across 0. So you just flip it. If it's positive, it becomes negative. If it's negative, it becomes positive. If it's an arrow, if you're representing a number like an arrow and you're taking the opposite of it, then you want to just take the, switch its direction. So you just flip it. It has the same exact length. So the opposite of negative 4 is that. Okay, so you might remember rules, like you see two negative signs right next to each other, it's a positive. Well, this is what it means, and I really encourage you to think about meaning, grounding your understanding in meaning rather than remembering rules, because you know what? It's actually easier. it might seem initially more difficult, like just tell me the rules, I just want to memorize them, but rules are so easy to forget and they're so easy to get confused because you're like, if the two negative signs are right next to each other, do they become positive? But then I see things like this, if I've got negative x minus x, people see two negative signs and they think that that might be 2x, right? Because they remember some rule about two negatives make a positive. So you want to be careful to ground all your understanding of rules into actual meaning making so you can visualize what's going on. The thing I want to talk about numbers is we can represent numbers with letters. If we don't, well, for various reasons, we can represent numbers with letters. We can represent a number in general with a letter if we just want to say something about numbers in general. For example, if I wanted to say this, that means that the opposite of negative x is always going to be x, no matter what x is. So this isn't telling me a relationship between any two numbers. This isn't telling me that x is a specific number. X represents any number in general at all. Another way that you can represent letters to represent, another way to use letters to represent numbers.
Another way to represent letters by representing letters in
Another way to Another way to use letters to represent numbers is if the letter represents a specific number that you might not know, but you might want to solve, you might want to find out. So for example, if I said, I don't know why you would say this like without context, but let's say randomly somebody asked you, hey, if you double a number, you get 10. What's the number? All right, so you double a number and you get 10. What's my original number? So there's an equation that represents that statement. You double a number, you get 10. This letter right here doesn't represent any number in general like it does in this equation. This letter right here represents a very specific number that would make this equation true. So that's called the solution to the equation. The solution to an equation is the number or numbers that make the equation true. And in this case, that's going to be x equals 5, right? And there's only one solution there. There's only one number in the world that you could double and get to 10. This equation right here would have an infinite number of solutions. Any number would be the solution. This is a statement that the opposite of negative x is going to be x. This is saying what number, this is saying there is one specific number that if you double it, you get 10.
So if there's x's on both sides of the equal sign, then the x isn't a number.
If there's x's on both sides of the equal sign, it might be a statement that is true for all numbers. It's not a specific number or a specific set of numbers. It might be true for all numbers. Or it might be not true at all. You could have a false statement. Like I could say 3x equals 3x plus 2. So there's an equation. There's x's on both sides of the equal sign. Is there any number that if you triple it, that would be the same as tripling it and adding 2 to it?
But is there any situation where there's x's on both sides of the equal sign and then x equals just like one specific number?
Yeah, so you could have x's on both sides of the equal sign and x could equal one specific number. You could have 3x, oh, so let me just write this here. This has no solution. If I could say 3x equals 2x plus 1, I have x's on both sides of the equal sign, but this equation is not true for all numbers. It's true for a specific number, right? If I double a number, then I'm gonna get the same thing as if I triple a number, I'm gonna get the same thing as if I double it and add 1. What number would that be true for? Look, we're gonna get into algebraic techniques later, so you might not know how to solve this. You might just sort of think about it and come up with an answer. You might do some algebra and come up with an answer. The answer is 1. So there's only one solution to this. So the x in this equation represents the specific number 1, and not numbers in general. The x in this equation up here represents numbers in general. So you can't really know automatically what the equation means without kind of thinking about it and thinking about the meaning of it. Another way that we can use...
Just gotta think about it really hard.
You got to think about it really hard? Well, play with it. Start messing around. Like, what does this mean? Try to solve it. You know, if you get a statement that is just true all the time, then your original equation was probably true all the time. All right, what about this? What if I said y equals 2x? Here I introduced another letter. So in that equation, I got a letter represents a number, I've got a letter represents a number, or numbers, or sets of numbers. What this means is that these letters represent a relationship. So there could be an infinite number of solutions to an equation, but they're kind of constrained by a particular relationship. So this is just saying that y is all the numbers, that's twice as much as x. And x could be any number, and y could be any number as long as it is twice as much as x. Roxanne has twice as much money as Sadie. Okay. Well, so in this case, y would represent the money Roxanne has, and x would represent the amount of money that Sadie has. Let me say that again. Y represents the amount of money that Roxanne has. X represents the amount of money that Sadie has. Do I know how much money Sadie has? No, I have no idea. Sadie could have any amount of money under the sun, but whatever she has, Roxanne has twice as much. So it's an infinite number of solutions to this equation. And those numbers represent those infinite number of solutions, but they're constrained by this relationship that they have with each other. Letters represent numbers in those three distinct ways. There's all kinds of different vocabulary that you might have come across in previous math classes or science classes or social science classes or future math classes. You could have variables, you could have parameters, constants, coefficients. So here's just some quick questions. So does this x represent numbers in general, a specific number, or a relationship? Yeah.
A specific number.
All right, a specific number. What about this? Is that numbers in general, a specific number, or a relationship?
Specific number.
It's a specific number. What about this? Is that numbers in general, a specific number, or a relationship?
One would work.
One would work. Would any other numbers work?
Two would work.
Two would work. Would any other numbers work?
Three.
Three?
4.
Yeah? What do you think?
-1 would work.
-1 would work. Would 0 work?
Yeah.
What do you think? Is this specific? Is this x represent a specific number or a specific set of numbers? All numbers or a relationship? It represents all numbers. So this is just something true about all numbers. No matter what x is, no matter any number you add it to itself, you're going to have two of them. That's all this thing says. This is sort of the definition of what multiplication is, maybe, right? If I have two of something, that means I have the thing plus that thing. What do you know about this number right here represented by this dot?
Negative number.
Okay, x is a negative number. How do you know it's a negative number?
It's to the left of 0.
It's to the left of 0. I'm not going to edit out this stuff you're
Okay.
saying. So, okay.
None of these people will ever meet me, and
No,
they don't know what I look
They
like.
have no idea who you are. Okay, so x is a negative number. And I'll say, what do you know about negative x?
To the left of 0.
Negative x?
It's to the left of 0.
Where is negative x on this number line?
It's a negative, so it's to the left of 0.
Tell me, okay, I'm right here. This is x. Tell me where to draw negative x.
On the other side of 0.
Right here.
Should you say that that is the negative of x, or should you say that it's, should you say it's negative x, or is it the opposite of x? Because when we were talking before, we said that like a negative number is to the left of 0, and the opposite of a number, you flip it over 0.
I know. I did. So here's x, it's a negative number because it's to the left of 0. What do you know about negative x? And I wrote it here, I didn't write it out negative x, but this is this negative sign x, right? Well, this sign means the opposite of it, right? So just like you said, you flip it. So negative x is over here. Well, this number right here, I call it negative x. You could call it the negative of x. You could call it the opposite of x. Typically, we just are kind of lazy and we say negative x. What do you know about negative x? It's a positive. You don't need to stop.
But
All
it's
right.
fun.
It's
Did you have
a,
them guess my age at the end of the quarter?
okay. Is this confusing? Is this confusing?
Yes.
Yeah, it is confusing. Negative x is a positive number. Ugh.
So x is a negative number, but x is not negative. Like the x that's to the left of the 0 is a negative number, but we don't say that it's negative x, even though it is a negative number.
Yeah, and here's one way to wrap your head around that, is that when x represents a specific number, like it does right here, the sign of that number is included in the letter. Like x represents a number, and a number can be positive or negative. And whether that number is positive or negative is included in the letter x. So like, for example, like what number could this be? Let's say like x could be negative 99, right? I don't say negative x is negative 99. X is negative 99. So the opposite of negative 99 would be this, right? And that's going to be 99. So the reason I have this example is it's really important that you wrap your head around the fact that when you use a letter to represent a specific number, the letter includes the sign of that number.
The letter includes the sign of the number.
Okay, let's see. Here's 0. There, I'm going to call that x, right? Okay, if that's x, then the opposite of x is when you represent a number with an arrow and you take the opposite of it, you just flip it. So here's 0. I'm just going to flip it. It's going to be between the same two numbers, although it doesn't have to be. Okay. So if this is x, this is going to be the opposite of x. The opposite of x is written like that, so it's like negative x. I would just say that's negative x. What is negative x? It's an arrow. I drew the arrow entirely lives to the left of 0, but when you're representing numbers with an arrow, where it lives on the number line is irrelevant. What matters is how long it is and what direction the arrow is pointing. The arrow is pointing to the right, so this number is a positive number. Let's say something like this. Negative x is a positive number, which kind of is confusing. It is confusing. It's true. X is, what's a negative number?
Negative 8.
Negative 8. All right. So then we flip it and take the opposite. What do we get? The opposite of negative 8. That negative 8 is included in the x. So this is the opposite. X is negative 8. So it's the opposite of negative 8. Opposite of negative 8 is going to be 8, right? So this thing right here, its length would be 8, and it's pointing to the right. So this negative x is a positive number. Negative 8, or the opposite of negative 8, is going to be a positive number. That's pretty much the end of chapter 1. I really encourage you to read it, and you have to do all the exercises, turn them in, look at Canvas page to see when they're due. Contact me with any questions at all. I really like it when students come to my office hours. I love tutoring students even more than I love teaching. And thank you to my off-camera crew. You're awesome. Whoop, 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 blah, 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 videos.